a coordinate plane. We need to be able to plot points in a coordinate plane. I'm going to give you a really quick review. We should all be able to plot points in a coordinate plane. That's something you've probably been working on since 5th grade, maybe 6th, but probably 5th. These are 4 ordered pairs. Ordered pairs are always in this form. The first term is always x, the x coordinate, and the second term is always the y coordinate. The x tells you how far to go left and right. The y tells you how far to go up and down. We always start at the origin. Origin means beginning, so we always start at the beginning. We follow the directions for our x coordinate, and then from there we follow directions for our y coordinate. So we're going to plot these 4 points. We're going to draw lines that connect them, and then we're going to decide is it a parallelogram, a triangle, a rectangle, or none of these. Okay? So we're going to go ahead and plot 2, 1. We're going to start at the origin. Also remember which way positive and negatives go. When you're talking about the x coordinates, positive is to the right and negative is to the left. We're talking about y coordinates, positive is up and negative is down. So if we plot these points, -2, -3, start at the beginning, the origin. We're going to go left 2, because that's negative on the x coordinate, and then down 3, 1, 2, 3, because that's negative for the y coordinate. And we're going to do that for all of these. So for -3, go to the origin, right 4, and down 1, 2, 3. You guys can probably plot these without me. It's okay. We're going to start the origin. Go right 7 because it's a positive 7. And we're not putting the point yet. And I got to go up 2 and then I plot my point. Remember, the coordinates are basically your direction, right? To tell you where the point is. 1, 2. Go back to the beginning. Go right 1. Up 1, 2. If I connect my dots. Very much looks like a parallelogram, but remember we can't go by that, right? The easiest one in this situation to do, we have a pair of sides that we can count easily. If it's horizontal or vertical, remember up and down, undefined slope, those are easy. We know we can either count for the horizontal, we count for the length, and then it's easy to find the slope as well. So these horizontal sides here, opposite sides, we can tell if they're congruent, so let's count from one vertice to the other. So 1, 2, 3, 4, 5, 6. There's 6 there. 1, 2, 3, 4, 5, 6. So the sides, so this side and this side are congruent. Make sense? So the one shortcut that's easiest to use for this one is this one right here. One pair of sides is congruent, we have. Now, are they parallel? So let's look. So remember, parallel means the slopes are the same, right? So parallel means the slopes are the same. We've covered this already. We're writing it as a quick review, but we know that parallel lines or segments that follow parallel lines have the same slope. We also know that perpendicular lines have the opposite reciprocal. Right now, we're not concerned with perpendicular, only knowing that if we compare their slopes and they're the same, now we can say these are parallel. So we're going to look here. This is a horizontal line. If you remember, if you had Miss Rayleigh, Holy Buck. So this is a pretty cool little shortcut I didn't ever use to teach until I came to Leon. It means a horizontal line, H for horizontal. That's technically a 0, an O, but we should know that it's 0 slope. And it's going to be a y equals equation, right? And this box means it's going to be a vertical line, up and down. It means the slope is going to be undefined, and it's going to be an x equals a number equation, right? So that's a shortcut, and it is helpful. So horizontal line. So these are 2 points on the same horizontal line, so we know that the slope of this is 0. The slope of this is 0. So both slopes are 0, right? So now we can say that this is parallel to this. So if this side and this side are congruent, and that same side is parallel to that same side, now we know it's a parallelogram. So far, so good? Okay. Y'all caught up with me? Okay. 3 vertices of a parallelogram are shown in the figure below. Give the coordinates of the 4th vertex, and we're going to call that 4th one G. I'm going to call that D. So we have 3, right? A to B, B to C. What we need is C to D, which would also be D to A, right? So one point we connect the other 2 sides. So what we can do is we can use this relationship from B to A. That slope, or that relationship, will be the same as from C to our unknown D. Okay? So what we're going to do is we're going to look at what is the rule created here between these 2 vertices. So in other words, how do we get from B to A? Do you guys have how do we get from B to A in your notes? No? All right, let's put it in. I labeled the points just because I can talk to you about them. You don't have to label the points. I labeled them just so we could refer to those. Oh, great. Okay, I got you. Did the memo go through? Yeah. Okay, great. And I couldn't see it on my end, and I was concerned, so I did actually remember to bring cash. Okay, thank you so much. I appreciate it. Thank you. All right. Okay. So D, I know if it's a parallelogram, D is going to be somewhere around there, right? So I need the ordered pair. If I'm going to plot a point, I have to know its ordered pair. So it's a lot easier than you think. How are we going to get from B to A? We need an x-coordinate and a y-coordinate. We're going to look at our x-coordinate and our x-coordinate, then our y-coordinate and our y-coordinate. Our answer is going to be an ordered pair, an x and a y-coordinate. So far, so good? Okay. Please put your hand up for me. All right. So how do I get from B to A? Well, let's do the x's first, right? B, the x term is 0. A, the x term is 5. So how far apart are B and A as far as x's? 5. So we're going to go right 5, right? So right 5. Now, once we get to right 5, do we go up or down to get to A? Down. So we're going to go down how many? Yes. So between -2 and -4, that's down 2. So right 5, down 2. So now all we have to do is do the same thing. We're going to start at C, go right 5, down 2. So do the same. Go from C to D. It's going to be right 5, down 2. We're going to do that together. I'm going to let you go ahead and fill it in. Tell you right what I wrote. So there are no grids on here, and it forces us to look at the coordinates, right? If we were on grids with the little boxes, we could just count, and that is a little bit easier, right? But they didn't want us to be able to just count, so that's why they didn't give us a grid there. They want us to know that in between those x-coordinates, we have to have 5 units. Now, it's pretty easy to go from B to A because our first x-coordinate was 0. So it's easy to see, oh, the difference in those is 5, right? But from the C to the D, we are going to go right 5. So we're going to start here. and we're going to go right 5. So if I go from this point to the y-axis, how many is that? 3. But I need 5, I'm going to go 2 more. So 1, 2, right? So what is my x-coordinate going to be? Very good. Exactly right. So once we're at our 2, how far do we go down? We go down 2. So our y is 7. So if we go down 2, down is going to be what? 5. From 7 down 2 is 5. So our ordered pair is over 2 and up. I'm just guesstimating here, but up 5. But we have the ordered pair. We have the exact answer. But you will see, and you don't have to draw it, but just giving you a visual. From here to here, looks like a parallelogram, right? And it is a parallelogram because we kept that relationship. Mine's looks like a wonky one. Looks like I'm giving you some sort of weird perspective drawing. But you get the point, right? Does that make sense? Pretty easy? Any questions on it? I mean, it is easy, but I don't want you to feel like it's too easy to ask questions. It's never too easy to ask a question. Okay. What if they give us a figure? The quadrilateral looks like a rectangle. The rectangle has opposite sides that are congruent for right angles. A rectangle is a parallelogram, but we have to be able to prove that this is a parallelogram. So we can use any of our sheets right here. This is the one we're going to use. This one is one of the easier ones because it only involves 2 sides, right? Because one pair of sides is congruent, and that same pair is also parallel. We don't have to know anything else, right? So if we can find the slope of those 2 sides, and we can find the length of those 2 sides, we can say that this is or is not a parallelogram. All right? Remember, just because it looks like it's a parallelogram doesn't mean it's a parallelogram. So I'm going to draw them all so they look like parallelograms. We have to prove it. All right, so these are the ordered pairs they give you here. It's already plotted. So what we're going to do, and this looks like an example, I just wrote this because I can't see my screen. You guys can see that on your notes. You don't have to rewrite that. However, we are going to use the distance formula and the slope formula here. We've already worked with both of those formulas, and they're both on your reference sheet that's on the home page, which means you'll have access to that on the POC, which means that I can give you these formulas for the test, right? So you don't have to memorize these formulas, but you should be very familiar with them, okay? And know how to use them. So the first thing we're going to do is we're going to start, I'm going to have you guys write the distance formula on your notes. I've already typed it on mine, but write this on yours because we're going to use it first. Because the first thing it asks us to do is to find the length of JK and the length. Let me make it bigger. It asks us to find the length of one pair of opposite sides. So JK and GH, if you look at the diagram, they're opposite sides. We could do the same thing with the other pair of sides that they didn't give us. Remember, once we prove if one pair of sides is congruent and parallel, then the other pair has to be. Because that's the only way. That's how we know it's a parallelogram to begin with, right? So by definition, using our shortcut there. So they could have picked the other opposite side. It doesn't matter. It's easy, just as easy to do either way. But since this is the format, this is one of your questions from Alex, we're going to use that one. That pair of sides that they asked for. To find the length of JK and the length of GH. So we need the x's and y coordinates for JK and GH, and we find the length separately, and then we compare them. If we get here and the length of JK is the same as the length of GH, then now we know those sides are congruent. So far, so good? Okay. I made myself a little sheet or a little template to fill in here. Remember, your calculator will do all of this for you if you just enter it in the same order. Just enter it just like it is once you fill in the formula. So you do not have to turn in work for this assignment. Remember, you should be doing this work on paper, and then giving the answer. So I'm going to go ahead, I just gave myself this, just because it was easier for me to fill in. So it's x minus x, right, squared, plus y minus y squared. So I need to be able to see these orders here. So jk, x and y, x and y. These are the endpoints of jk. We use those to find the length of jk. The length of gh, we're going to use this. So we're going to start x. So the formula says x sub 2 minus x sub 1. But that order doesn't matter. We just have to make sure if we use this x first, we use this y first. Right, so that's what we're going to do. X minus x, negative 1 minus 2, plus y minus y, negative 6 minus negative 8. Don't forget, minus negative 8. It's not just minus 8, right? What's a minus and negative? A positive, yeah. You don't even have to remember that. If you enter what's under the radical, just like it is there with the parentheses, use the x squared button, and all that, you don't even have to know that a minus is negative is positive. Your calculator does it all for you. And we are not going to take the square root. I meant to, let's see if I can go down the description. Nope, not what I want to do. Okay, so it says give exact answers, not decimal approximations, which means we're going to leave it as a square root. We're going to leave with the radical on it. That's all that means. So here, I'm going to kind of do it step by step. But once again, you don't have to. You can do it left to right on your calculator. Negative 1 minus 2 is negative 3, and that's going to be squared. Plus negative 6 plus 8, that's going to be 2 squared. Be careful. You do need to put the parentheses around that to square it, because it's a negative. You don't need any parentheses when it's a positive. So this is equal to the square root of 9 plus 4. Does that make sense to everyone? And we just add that 9 plus 4 and leave it under the square root. So we know the length of jk is the square root of 13. The square root of 13 is 3.605551275. It's an irrational number. It goes on forever. It's about 3.6, but they said no approximations. The only way to give an exact answer here is to leave it under that square root symbol. Make sense? Okay. So we know that jk is g8 is a square root of 13 long, and now we're going to find gh. So what is x minus x? What am I going to use for gh? Can you tell me? Thomas, can you tell me? How am I going to send that first set of sentences? X minus x, right? And we're doing gh. Right? What's it? Very good. Very good. So x and y, x and y, x and y. So 6 and 3, so 6 minus 3, all squared, plus, and now what are we going to put in the y's? Kingston or King? What are we going to put in the next set of parentheses? This was x minus x. We need y minus y. What y's are we talking about? Look up here, Betty. Look at the board. Y and y, right? G and H. G and H are the endpoints of segment GH, so that's what we use for that distance of that segment. So it's negative y minus 1. Does that make sense? King? Does that make sense? Oh, I'm calling you. Are you? Oh, yeah. Made me think I was calling you the wrong name. Funny, sometimes after a long break, I'm on names. But I was right. All right, 6 minus 3 is 3 squared. Negative 1 minus negative 1. If you square that, so that's negative 2 all squared. So what we have here is the square root of 9 plus 4. We can add what's under that radical. So they're congruent. So JK is the length of JK, or segment JK is congruent to segment GH because their lengths are equal. So far, so good? Any questions? Yes.
So when we're putting it in formula, it doesn't matter if you do like x2 first or x1, just put it in.
No. So if you want to do x2, so if you want to do 3 minus 6, that's okay. And make sure then you do 1 minus negative 1. Because you've been in the same order. That's all the subscripts are for. To say, look, if you do x2 first, you got to do y2 first. So it's really not first or second. It's just a label. They have to be together. All right, so now we're going to go ahead and write, you're going to write in your notes this slope formula, because we're going to find the slope of JK and GH. So down here, you're going to write this formula. Right down here where my star is, right here. So right here. And I don't really care if you put the subscripts, but it does remind you that these have to be part of the same ordered pair. These have to be part of the same ordered pair. The most common mistake on the slope formula is mixing up the x and y coordinates, not putting them in the same order. And also, don't forget the y's going on top. Okay? And I wrote my order pairs down here just so I could see them, so you don't need to write those again. All right, so for finding the slope of JK, we're using x and y from J and x and y for K. Those are the endpoints. So let's look over here real quick. I've been talking about it, but not really pointing it out. So segment JK is named by its endpoints, right? So we want to find the length of that, we use those two endpoints. If we wanted to find the length of this side, we use, this would be segment JH, and we would use those endpoints. We're not doing that. We don't need the one opposite pair. Okay, so the slope of JK. So we're going to say the slope here. I'm going to say the slope of this first one, step 1, y minus y, negative 6 minus negative 8 on top. Why did I put a y there? Negative 6 minus negative 8, oh, that's a plus. And then x minus x, negative 1 minus 2. So if we simplify that part, and remember, you could just do that on your calculator, 6 negative button minus 8 negative button, it'll tell you that's positive 2. Negative 1 minus negative 2 on your calculator, 1 negative button minus 2 negative button equals negative 3. We're going to move that negative out of the denominator, and we're going to say the slope of JK is negative 2/3. Okay, so far so good? You with me? Writing it down? Okay. So here, now we're going to find the slope here. So the other side. So it's going to be x and y, x and y. So what's going to go on the top of my fraction here? Amaria, what's going to go on the top of my fraction? -1 minus 1, yep. And what's going to go in the bottom of my fraction, Dahlia? This was y minus y, so we need x minus x, right? Say it again. We're on GH. Yes, 6 minus 3. So -1 minus 1, do that on your calculator. -2 over 6 minus 3 is 3. And we can leave that negative in the top, it doesn't matter, but remember, just to prove they're exactly the same. So since the slopes are the same, then the sides are parallel. Remember, those two lines look like an 11, but those two lines mean parallel. See, you can see right when I just wrote that. Take your pencil up. So this is the first part of one of the problems. That's what it's going to look like in your assignment. And then the next one is a list. You see it on your notes. You can't see it on my screen yet. Is it a parallelogram, and how do we know it's a parallelogram? Or the criteria that we're using to decide if it's a parallelogram. So let's look here. So what do you think? From parts A and B, what can we conclude? The first one says the quadrilateral is a parallelogram because it has one pair of opposite sides that are both congruent and parallel. Is that what we did? It is what we did. So we got to the answer right away, right? Our sides are the same length, so they're congruent. That same pair of sides are parallel. So our answer is here. And I always like to go through and double check. So this next one says the quadrilateral is a parallelogram because it has one pair of opposite sides that are parallel, even though those sides are not congruent. Well, that can't be right? Because we know that can't be right. That's not in our list here, right? So that's a no. The quadrilateral is a parallelogram because of one pair of opposite sides that are congruent, even though those aren't parallel. That can't be so. The quadrilateral is not a parallelogram. No, we've proven it is. And then it says it cannot be determined. So that's not, none of those could possibly be the answer. This one's definitely right. There can't be more than one answer here. It doesn't really say for sure. It's not super clear. Could you give more than one answer? It should tell you that, though. But we've ruled out all the others anyway. Does that make sense, Tori? Okay, does that make sense, Vivian? Charlie, you good? Okay. Miles? Okay. Any questions for me? Okay, you can scan them and submit them, and your assignment's on Alex again. Remember, you don't have to turn in the work, but if you're not using pencil and paper or whiteboard and marker, then you're not doing your best. Right? You're not trying hard enough. You have to use pencil and paper for these things.